next to us, but they are there. So, okay, I'll introduce you now. Welcome everyone to our June Malaysian Mycology interest group under the Malaysian Society of Infectious Diseases, our June CME. We are pleased to have with us Dr. Boris Oberheitmann. Dr. Boris Oberheitmann started off as a research associate in medical physics at the University of Bremen, and he has had an illustrious career being a scientist and doctorate research assistant at the Department of Epidemiology and the Center of Environmental Research and Technology from 1996 to 2000. In 2000 to 2003, he was the coordinator and scientist for the research area risk research at the Center of Environmental Research and Technology at the University of Bremen. From 2003 to 2018, he was a managing partner of Q Bioanalytics GmbH. In that time, he was also the managing partner of Secret GmbH between 2007 and 2010. 2018 to 2019, he was a managing director of Eurofins Q Bioanalytics GmbH, and from 2020 June until now, he's the head of application development, microbiology and diagnostics, Bruker, Daltonics, GmbH and Co. KG. We are welcome to have Dr. Boris Oberheitmann with us today to have our June CME, and our June CME for this month is one step in technology, one giant leap in fungal diagnostics, a moldy application of MALDI. Dr. Oberheitmann, the floor is yours.
Okay, thank you, and yeah, have a good day to Malaysia here from Germany. I would like to share my screen, and I need some from the host the rights to share my screen here in this Zoom session. Maybe
Dr. Ken, share the, I think now, try now, Dr. Oberheitmann, whether you can share your slides.
Okay, now it's working, and I hope I can share it here. So now you see something, maybe? Is that right?
No, don't see any slides yet.
Okay. That is kind of strange. Maybe now.
Yes, your slides are clear now.
Okay, fine. Yeah, thank you, everybody. I will give you a kind of update of what is in filamentous fungi products at Bruker in Bremen here. My name is Boris Oberheitmann, and I'm the head of application development. That means I am working on all kinds of applications related to the MALDI biotyper and also the IR biotyper. And I will have a short overview in the next slides about, let me see how I can go to the next slide here. So I will give you a short overview about Bruker Daltonics in principle, and also about the microbiology and diagnostics division, which is the division of Bruker where the MALDI biotyper is located. I will give, for those who are not too much familiar with MALDI biotyper, also a small overview about the technology itself. And of course, my focus will be today on the filamentous fungi, and I will have show you a little bit about the development and how it evolved in the last years. I will show you some publications which were published quite recently about the previous versions of our module and our library, and then I will come to our latest development, which is the fungi module 2022. and I show you some data we did for our performance characteristics studies here, because we launched this product as an IVD CE in Europe. And for this, we did some analytical and also clinical studies, and I will give you a short overview, and hopefully we will have a questions and answers sessions afterwards. So let me start with a short overview of what is Bruker. Maybe many of you already know us. Bruker is a worldwide company. We have 7,400 employees worldwide, and our major manufacturing sites in North America, in Europe, and in Asia. In total, they are 14. So we had acquired some companies in the last years, and in total, we have about 1,200 employees dedicated to R&D. And this is also reflected by the high number of patents which are pending or granted. It's around 4,000. So that is always a proof that we are at the top of the developments in many different markets, and Bruker holds position 1 and 2 in 70% of the markets we are active in with our portfolio. So I can give you a small overview. Bruker, the core of Bruker is the NMR technology and EPR spectroscopy. We have clinical imaging. We have the mass spec side, of course, the MALDI biotyper for microbiology. This is where I'm working on, but we have also MALDI-TOF for imaging applications, preclinical ones. We have atomic force microscopy, FTIR. One of these part is the IR biotyper coming from this side. We have X-ray diffraction, and also further X-ray for semiconductor testing and so on. So quite high-end products. The latest one you can see here. These are not the exact scales here. This one, I mean, a human being would be. Do you see my mouse here on the screen?
No.
No. Okay. Maybe
yeah.
I. Can you see this laser pointer now?
Yes. Yes.
Okay. And I will take this. And so these are instruments like the NMR, a really big machine. Well, a human being would be in the height of that here. And here the timsTOF, which is a very high-end MS device. We working for the biotyper with the smallest one, a benchtop system, and I will later go into detail about this here. Further application and instruments built by Bruker, for example, nanos, CT, and other things. So Bruker is quite an innovative company, and with our division, Microbiology and Diagnostics, we are addressing, of course, the healthcare solution market, besides all kind of research applications. So, and in that, we focus here on the MALDI biotyper, and what we say that microbiology identification has significantly changed already with this invention worldwide. We have around 5,000 systems installed worldwide, and we are also expanding the applicability of this technology to many other fields, of course, in the microbiology diagnostic and the clinical diagnostic field. And one example for that is the identification of microorganisms in bloodstream infections with a very high speed, of course, where after 15 to 20 minutes after turning a blood culture positive, you can use the sepsityper kit and do a MALDI-TOF analysis so that you have results in a very, very short period of time. And of course, we are also active in the field of antibiotic resistance testing. Here is one of our products, the MBT STAR assays, carbapenemase and cephalosporinase activity. You can measure also with MALDI-TOF using these MBT STAR kits. I have to say that not all of these kits are registered in the USA, and if they are registered in your country, you have to contact your local Bruker partners to know what is available and what not in your country. So besides the MALDI-TOF applications, we also recently acquired some other companies which are active in AST testing based on broth microdilution to have an accurate MIC measurements based on the Micronaut systems from Bruker Merlin. And this is also a very interesting field, of course, because antibiotic resistance is rising worldwide still, although there have been lots of activity already to reduce this. But this is, in fact, a really a complicated solution worldwide. So we have here also some PCR tank. This is Bruker Hein, which is one of the companies we acquired some years ago, and they are also in the microbiology and diagnostics division. We have here PCR tests for detection also of some resistance targets, but of course in the mycobacteria field they were very active. We also have highly multiplexed PCR system based on a technology which is called liquid array technology, where some of 10 or 20 parallel targets can be addressed for syndromic panels, not only in virology, but also in enterointestinal applications. Also, we have some PCR methods addressing the mycology field. This is from our branch at Glasgow in the UK, where we have PCR-based tests also for some filamentous fungi. Of course, I already mentioned the IA biotyper, which is a system which is also not an in vitro diagnostic device up to now, but it addresses some epidemiology questions when you are looking for a strain typing in epidemiology and with outbreaks detection. You can use this device to find solutions to see whether or not an outbreak is from one source or not. So I will now switch a little bit to the back to the biotype, the MALDI biotyper again, and give you a short overview how it is working. And so you have you start with a colony on an agar plate, and a selection of colonies should be a pure culture, no mixed ones, and then you just take a kind of toothpick or a similar device to transfer the material, the bacterial or fungal or yeast material to a target position, and then you start the acquisition process of MALDI-TOF profile spectra, and this will be identified against our libraries. Well, what we are addressing with the MALDI-TOF is the highly abundant microbial ribosomal proteins. They are in the range of 2,000 to 12,000 Dalton, and we take up a spectrum with characteristic masses and intensity distribution patterns, which act like a molecular fingerprint. And we can compare these informations we get from this machine with a highly elaborated library of microorganisms. We have dedicated libraries for bacterial and yeast together, and for filamentous fungi is a separate library. We also have a separate library for the mycobacteria. And what happens then is that each and every, if you have an unknown spectrum, which you take from your measurement, it will be compared to each and every entry in our library, which is currently almost 12,000 entries. Oh, there was feedback, but it's okay now. Yeah, and that's how it works. I can show, and of course, the advantage of all this is that you only need minutes from starting from a colony and doing the MALDI analysis, which otherwise takes you a lot of time and a lot of work. So that we see here, have a short view on the latest software GUI, where you can do your layout for the target and measure it. You can also go into the spectra itself. So it will give you a log score, which is a value which gives you the information how good a spectrum fits to one of the entries or all the entries in the library. And the most fitting one will be displayed then on the machine. Let me just go one step back, how MALDI is really working. And here you see I have an insight into an instrument and what is going on there. So MALDI stands for Matrix Assisted Laser Desorption Ionization Time of Flight Mass Spectrometry. And the principle of it is that you have a target chamber where you place your target in, and then your system, your bacterial or fungal material you are applying to the target is overlaid with a matrix, and this matrix will bring in the ionization. So when you place the target here on this position, the laser will have an effect on the sample that ions are accelerated in this flight tube. You also have a camera here where each position and the laser beam can be seen in real time. And then these molecules, which is of course for the identification of organism, mainly the ribosomal protein material combined with the matrix, they are accelerated in this flight tube, and they are migrating to the detector unit at the top of this instrument. And the time, here you see a little bit of an magnification of it. Here you see molecules accelerated in the flight tube. And what the goal of this is that the time of flight, which is the TOF of the MALDI-TOF, will give you an information about the mass of this kind of materials, the proteins you are accelerating here. So the time of flight is then transferred into mass over charge ratio, And this is equivalent finally to the masses of the different proteins which are measured here. And this is a kind of a typical spectrum. You have the mass here on this axis and the intensity on the others, and these kind of protein patterns, the mass spectra, are compared to our library. So that's the basic principle. And currently we have the latest machine series is our Series 1 and Series mass spectrometer, and they have an easy workflow, and they work with a new Compass HT software, which is so much faster, and so that you can have the results of one target already within 20 minutes or something like that, when 96 positions can be loaded. So the time to result is, of course, very short. It is specific, it's quite robust and cost effective, and it covers at the moment for the bacterial and yeast around 4,000 species. So besides this, we have also some consumables around it. Of course, as one of the most important is the MBT BioTarget 96. This is a disposable target with some advantages over the steel targets, which are the first version of targeting. The biotargets have specific surfaces with an hydrophilic anchor in the middle of this spot, so that you don't have the that spots are not leaking or something like that. So you keep the material on the spot. That helps, of course. And also I will come to that later on for the filamentous fungi preparation method. It helps also because biotargets have a kind of rough surface, which helps you when you prepare a sample on a target because of this rough surface, and you can interact with the material very, very nicely then. Of course, one of our latest accessory machinery is the MBT Fast Shuttle IVD. This is a kind of incubator which is designed for further applications in the field of AST from the beginning, but we also use this now and validated it for the controlled drying process of the targets after applying the matrix to the target. And this helps especially in those environments where you have high humidity and where drying of the target might take long or is not really standardized as it could be. And with this device, you have really a nice tool where you have a period of time which is can be set in for the drying process in the instrument, and then you get a signal that the drying process is completed, so that you have nice and standardized workflow with this. And also with this, we have a performance gain over just air drying, as we found in our studies. Then there's the pilot, which is a guiding instrument to transfer materials to a position on the target. And of course, for a high throughput laboratory, we have the MBT Galaxy, which is an automatic application instruments to apply matrix and formic acid on the target. So as I mentioned earlier, we have this Sepsityper kit, which is dedicated to extract microbial material from a blood culture sample. So in the case when blood cultures flag positive, you can use this kit to process the blood sample containing this microbial material, and you can get rid of the blood components with it and have a pellet at the end with microbial material which you can apply then to the MALDI biotyper and close a important time gap we have in diagnostics of bloodstream infections. Here you see also, we mentioned it earlier, the resistance detection using the STAR-BL methods. And of course, the microbacteria identification as a separate kit now, which is now also IVDCE labeled and but not yet in the US available, and soon it will be also available in those countries which accept the IVDCE labeling. Here again, a kind of timeline about what was in the biotyper history. So the first machinery for the research application was already on the market in 2004. We had 2009 the first IVD labeled products for clinical microbiology. We introduced some generations since then of the MALDI-TOF instrument itself. It was the Microsoft Microflex LT. It was later on the LTSH. It was the Smart somewhere down the line here. Here it is in 2015. And now we have the Series on the market, which is the latest and fastest machine ever. So, and of course, we introduced the filamentous fungi library for the research use only. And this year in May, we did a notification for the IVDCE for it. So it will be launched probably in September for the customers, which is the latest library and a module addressing filamentous fungi, where we did some big improvements. And I will come to that later on. So just let me see here on the next slide how our bacteria and yeast library developed. And in the beginning, we started with, here are the reference entries, and that are the species which are covered with it. So at the beginning, we started with something like 4,000 entries, and it evolved over the time. And here, of course, the number of species are now in the 2022 release of 4,194 species entries in the big library. And also we improved a lot in this last update, the yeast identification by really thoroughly going through it and entering new entries in the yeast field, so that we have a significant better performance for yeast identification with the big library now. And meanwhile, I think it's quite something like a gold standard worldwide. We estimate that around 120 million ideas per year are performed using the MALDI biotyper. And so that's, of course, also in the field of the sepsis diagnostic. I already mentioned it. I can skip this a little bit because our focus is a little bit a different one today. So we have also developed the filamentous fungi library in the past. In the history you see here, these are, of course, up to the 2022 release only research use only products. And now in September, we will have available also the IVDCE labeled version of it. And here you see the reference entries. Because of IVDCE labeling, we went into the taxonomy, and we even excluded some of the extraits so that we have less entries, but with a higher accuracy. And now we have 222 species in it. All you know, because you are experts in the field, that fungal taxonomy is kind of volatile, I would say, so that there's many renamings and groupings and all these. Also, the DNA sequence information is evolving more and more in the field, and our library entries are all back up with, whenever possible, with DNA sequence information, which is in some cases so close together that there is no possibility at the moment to distinguish each and every species. This is the case for the ITS and other DNA-based methods, but it's also the case for the filamentous fungi detection or identification using MALDI-TOF, because in some cases MALDI-TOF can distinguish species where the DNA-based approaches cannot, and sometimes the other way around, so that we have a permanent transformation of our library and adapt it to the current taxonomical literature. So this is the reason why we changed always things in the library. We rename, of course, entries and so on. And that gives you the situation here. So currently we cover around 72, or not around, but exactly 72 genera. And when you look into the literature, you see always that at least the main, I mean, with this, with a low number of species, you can already cover 90% of the isolates in clinical settings. However, this remaining 10% is really a pain point for many of our mycologists, of course, because they have to use other methods and do sequencing, whatever they do after it. And this also is, on the one hand, laborious. It takes long time, and it is also costly. So that's the reason why we develop this further, and also have the idea of including an ever increasing number of species and strains and genera into the library in the future, not only in the pure clinical field, but also coming from environmental sources, so that our library should be as broad as possible. Although I can show you later on some results of our clinical studies, you see that the main species are, of course, Aspergillus species, and I will come to that later on. So let me just say a little, some words about the literature, the current literature. This is a publication from early this year from a group from Austria. And this is also a very nice paper, but, and this is one of the problems always when we see in the literature publications about our filamentous fungi library, they are, although it is published this year, it is based on the library 3.0, which is now, after that we had the 4.0, and now we rename it. We always name it like in the year, with the year where it is released. So the latest version is the 2022, and this is of course, in each and every library update, we introduce more species and so on, and we optimize the differentiation and so on. And and this is also the case here. So everything which is published is, in a way, even if it's published this year, might be something addressing the past. Also, the cutoff discussions, or those who already worked with the MALDI biotype, I know that maybe in the past we had a cutoff, like for the bacterial cutoff of the log score at 2.0, and now we have it reduced to 1.8. Here in these publications, they always address these questions, whether or not it is advisable to reduce the cutoff for we always discriminate between a high confidence and a low confident identification. It depends on how good spectrum matches the library entries, and that does not necessarily mean that the lower confidence level is wrong, and it does also not necessarily mean that this lower confidence level is equivalent to a genus identification. This is often considered as it, and in the past also Bruker was using this term, but from a taxonomical point of view, this is not really correct. It is, I mean, in many cases, it is okay because our library is constructed like that, but it is not really accurate, so that we turned over to call it now high confident and low confident identification, and not anymore genus level and species level. Although this is, yeah, in many cases correct, but not in all. So I want to show you some results here from this Austrian group. They did in total 184 isolates from clinical samples. Of course, here you see the number of the different genera in this, I mean, selection of strains, and as it is always the Aspergillus fumigatus and Niger and Oryza and so on. These are the top Tereus and the top scorer of what is present in clinical mycology. And here you see the overview of this strains, and then they use the extended direct transfer. I come later to the difference. The extended direct transfer as it was before, because they were using the old library and module, and also they after that we changed a little bit the workflow. So they used the extended direct transfer, which means you apply not only the material and then the matrix on the target, but you use a drop of formic acid and then apply the matrix. And different from that, they used an extraction approach where they this is a full extraction, how we call it, from the material taken from agar plate, and then used a small centrifugation step and so on, and then you come up with an extract of the material, protein extract. And as a third option, it is an extract from a liquid cultivation. I will also come to later to that. So, and here, these are the three workflows they were using in this study. And here you have high confidence identification and low confidence identification. So if you count that together, you have all which are above the low confidence identification threshold. And so this is the results they have here in the bottom line for the different kind of methods. It's getting always higher, this identification rate in percent here on the bottom line when you do the extraction. However, then they also used an in-house library, and this is something we always find in publication, that people using an in-house library because they had their own culture collection and used that. And in many cases, there were reports that it is superior to the Bruker library. So of course, we have to be aware that this is the 3.0 version, which is 2 versions under the current one. And also, in many cases, if you prepare your own in-house library, you will get in the future a little bit some of problems with the IVD in Europe, at least. I don't know how it will be in your country, because IVDR, the latest IVD regulation, requires always this kind of intense validation and verification of the method, and we do it within our IVDCE labeling and development process. And so this is always not in the in-house libraries because they can't do that in that way. But also the selection of strains which might be also in the library itself or are from the region might be closer, and we also try to introduce in the spectrum library also strains for some species from different sources, not from one country, but to have a diversity within a species in terms of different strains from different origins. So that's also a point why this might be always the case, that we found publications here with a higher performance of in-house libraries and not with ours here. Here's also a quite recent publication from 2020 about dermatophytes, and they used 193 isolates, and they used the direct transfer method, which is not with formic acid, and an extraction method, and they have quite high rates of identification already with both methods. Here they call it again species level and genus level, which is now high and low confidence identification, and which is also nice that some have already a good identification rate. And here a comparison of species level or genus level between the different methods and the classical microscopic or macroscopic inspection. So the agreement and disagreement, the agreement is higher when you do here the extraction method, of course, because the method itself, and especially when you use old fungal material, which is what you do in when you use microscopy or macroscopic evaluation of these samples. You wait until there are conidia and whatever. But for MALDI, it's just the other way around, that you should harvest material as early as possible. In the moment when you see a colony, a very a front mycelium, a very fresh one, you should exactly use this material, because all differentiation you want to have in macroscopic and microscopic evaluation, you don't need it's just the other way around, that conidia and spores, they do disturb this, because this is a quite significant change in the ribosomal protein content and so on. And also there might be in more differentiated mycelia, they have some secondary metabolites interacting with the MALDI process and so on. And that's always the reason why you should harvest the youngest material you can ever see and put it on a target ideally with our new workflow, which I like to demonstrate here. So those of you who had some experience already with the old workflow, so in former times we had the DTs, which is the direct transfer method. You transfer material and overlay it with matrix, and the EDT, which was an overlay with formic acid and then with matrix. And we had this extraction method, either directly from the plate or after a liquid cultivation. And we now changed this standard workflow a little bit, and which is, I mean, significantly better. If you remember the the identification rates of the publication from Willinger, the Austrian group working on it. You can see later on the next slide how we evolved from that. So what we are doing now is we have two options to start. We start with a modified EDT workflow, which we call MIT, also mycelium direct transfer. And this one starts with laying a drop of 1 microliter on the target of formic acid, and we use only biotargets for this. Because, as I told you before, these biotargets have a rough surface, and if you drop this formic acid and then deposit the fungal material on the spot, you can use a toothpick, and be aware it should be a polished toothpick, not soaking too much of the formic acid, because what you do is you deposit 1 microliter of the formic acid on this target, and then you dip with a toothpick in this drop, and with this, because formic acid is a quite strong acid, you can cut the material on the plate like a knife, because of this very, very small amount of formic acid, you can easily harvest young mycelia and transfer it to the target, and then you have the rest of this droplet on the target, and then you agitate it a little bit on this rough surface, and with this really small change, we reached a very high identification rate already with this extended direct transfer method. So, and in some cases, of course, some species have other kind of mycelia structure, they have cell walls, whatever. They do not work all this as well. So you have also some samples which are not identifiable after this procedure. And then if you have a no ID, you can just go into this overnight culture. And we also use some different incubators here now. And the rotator, of course, is the most important thing. And then you do a short extraction. Well, I know that many of our customers do not like this overnight culture. However, this is really the highest possibility to reach an identification. It's almost 100% when you do the overnight culture. Everything what is in the library, and you do this overnight culture with this rotator incubation is detectable. So you, on the one hand, you lose this one night of cultivation, but you gain so many time, because you don't need to wait for microscopy or to differentiate the mycelium or whatever, or you do not have to wait for a sequencing result. So this one night gives you really, in the few cases where you need it, because most of them are already in the short workflow with the EDT, okay. But if not, put it overnight in this broth, do the small steps of centrifugation, and you will have a result. If it's in the database, it's almost in all cases that you get a result. Second option is, of course, still an extraction from plate. If you like to do it, but this one is so easy, and already you reach so many identifications with that. So this is just a second option. Also, if you don't want to wait this night, you can do it as a second step, but it's not mandatory. No? So the workflow is not that if one is not working, you take two. The workflow is now, if one is not working, you go in the overnight, and if two is not working, you go in the overnight culture. That's how it's planned now. And then here you see a picture of our our MBT fast shuttle. This is in a closed state, but you use it with an open lid. You have a kind of programming here. You start it, and after some minutes, it gives you the sign that everything is dried. And also, this one step for improving the results was the change of the formic acid as a first step, and the second improvement comes from the standardized drying procedure here on this device. And both together give you the results as you can see here. So as I told you, we reduced the cutoff point for high confidence identification to 1.8, and for a low confidence identification to 1.6. And here you see the EDT. We had here a kind of a panel of different organisms which are most abundant, of course, but also we want to cover some genera here. And we took this as a panel always for our, and also in our clinical study sites as a challenge. Paddling is too much because it's not challenging. And here you see after EDT with a green log score, which is a high confidence identification, you have already 83%. And in the last paper, it was, I mean, something like 48 or so, what I showed you. And with a log score above 1.6, which is almost the right, so that there it is, even if it's a low log score, the results are quite accurate. It's 94% here. And here, this is for the EDT, and this is for extraction from agar. And of course, here, extraction from liquid, it is really, in this case, always 100%. So, and that's why I really recommend to do it. Here you see also a kind of box plot showing it here, the results from EDT. And here, this one are no IDs or flat lines, which also might occur. These are totally gone with this liquid extraction, and you have highest and best identification here. So we use this kind of a rotator, and which can be put in a incubator very easily. It's not so big, and of course, as you do not need too many of it, you can use this small device. This rotates always the whole night, and you need it because by rotating this, there is no differentiation starting. So from the fungal material, you have this very fresh material, which is very easy to process. Yeah, so here just one comparison of the steel target and the bio target. I mentioned it already. Here you see that the steel targets in many cases produce 0 lines because this is the lack of this rough surface. It's a very a surface which does not lead to disruption of the cells, and here you have a higher disruption of the cells, so that you can reach also better identification rates here. So, and also I told you that we're using the MBT fast shuttle, and here you see a set of data where we compared the identification rates of both systems. And here this box plot shows that there's a higher variability and even some outliers and also some flat lines. And using the shuttle drying process, it is very in a very narrow scale, so that you even have a box here and only a few outliers. And if you apply statistical analytics, you say you can statistically, based on a p-value here, that this one is significantly better, and you have the mean is higher than the mean of this. So so we also compared some some culture media, sabro agar. Then we had this very nice IDFP plates with a membrane on it from Conidia. Many of you might know them. They also, we can recommend these Conidia plates as well. They lead at the end to a good harvesting, and you don't put any agar material or something like that because it's growing through this membrane. Here also statistical and analytics, we use also malt agar, which is a little bit more variety in it and with lower identification rates, but it's still statistically not different from the other two ones. But you see here, this is the most accurate one. Then we did repeatability studies within our analytical part of our IVDCE validation work. And here you see some day-to-day variabilities, which are all not statistically significant. We have an instrument-to-instrument variability, which is nice. Here, no difference. And also operator-to-operator. And yeah, we also did some tests on limit of detection, which is a little bit tricky in the field of fungal analysis, because here you see the EDT method, the extraction from agar method, and the extraction from liquid method. And what we compared here with the EDT, because you can't really dilute the sample. So what we have, we say that 3 to 4 millimeters on a toothpick of fungal material is the ideal amount of material. And then we went under it and went over it a little bit. And here in the extraction methods, of course, we can just dilute the extract, which is more easy than to do a real limit of detection study. And here you see the log score above the number of isolates with the log score above 1.6 and the percentage of it. So you see here, of course, that they are more efficient here. And in the next slides, I can show you also how it looks in a plot here. This is the EDT method, and we had, this one is the amount we are recommending, 3 to 4 millimeters of material on a toothpick, but the others still have a high log score, no problem. And here you see this is extraction from agar, and if you dilute this extract by 1/4, it is no problem. So you still have high log scores. If you dilute it 1/10 and by 20, you are below the detection limit here. This same is true also for the liquid extraction. So this means what we recommend is far away from the limit of detection. So, and that is why we feel that our workflow is quite good here. This is a kind of summary of what I told you before. Let me just go into the clinical study we performed together with 2 clinical sites. And here you see, it is also on the next slide, what kind of isolates they used. They had in the prospective and retrospective way. So these are all clinical isolates. But if you only, in a study like that, go for a prospective approach, you will have always Aspergillus fumigatus, then you do kind of Aspergillus study and not something covering did I lose you here now?
Your slides disappeared.
Yeah, okay. So I was a little bit, maybe. I try it again. Let me know if you see my slides now.
Yes, yeah, you can see them.
Okay, okay, fine. So, and now I have to switch a bit, sorry. So, yeah, this is the last part of it. So in total, it was 254 isolates. And what you see here on this slide, you have this main of them are, of course, the known Aspergillus species. And finally, all the others, they occur once or twice or whatever. And that's the situation how it is always also in the real clinical world. And that's the reason why we want to expand our library as much as you can. So because you have many of species which are not very frequent, but in the case you don't have them in the library, you can't have a swift result for these kind of species. So that's the reason here. So in total, many of them only appeared once in this set of data, so that we have this strategy to expand as much as we can our library. And here you see an overview of what kind of biological materials or patient materials these isolates came from. So I also, of course, bronchial secretion is the most abundant ones, and but all from all kind of other sources here. That's the message of this table. So, and here, these are the results of the two sites and the combined results here. And here you have identification of, and compared to the reference method with the EDT here, it was already 91% for both sides, which is quite good. And here, then identify the remaining ones identified with the liquid method. And here we have 99% using the whole workflow from EDT to the liquid. We have really good, even also from agar, followed by extraction. So this shows you that here you have already 91% in this study, and here you have 99% in this study of this 255 isolates from a clinical setting here. I think this is really a big advantage we have here compared to everything which is published in the literature. And so I think this brings the fungal identification one step forward, and for the sake of the patients and of course of the workload you all have in your labs then using this technology. Okay, thank you for your attention, and I'm happy to answer questions.
Thank you, Dr. Oberheitmann. There are a few questions. One in the Q&A is from Dr. Haneez Shazwani. She asks, for extraction from liquid, how fresh should the colony be to get an accurate result?
As fresh as possible. So you do in the moment when you see turbidity in your liquid culture, you can do the centrifugation steps, and this is usually enough material to use it for the further identification. So as less as possible. If you see anything turbidity, you can use it. And if you wait too long, the results will be worse. So it's no advantage of waiting.
So as fresh as possible.
Yeah.
Okay. We have a question. We have actually Dr. Jacinta has a few questions, so I'll go through one by one. Her first question is it possible to distinguish species within a species complex, such as Fusarium solani species complex?
Yeah, we are trying to resolve as much as we can for different ones. So the taxonomy itself and also the DNA-based taxonomy is in some cases overlapping. So I can't tell you for the exact species you will mention, but in principle, it works, but not in all cases. And sometimes MALDI does not really distinguish. In other cases, we can do it by including more strains in it, or even can do a kind of subtyping or something like that to find further peaks which are distinguishable. We're working on that also, but it depends, of course, on the species itself. And always when you have problems, you can also contact us and send us strains or something like that. We can work on improving our database. This is also a message I want to send from here, that we are very open for all kinds of cooperations in this field.
Okay. Her next question is, you mentioned that it is possible to identify microbes from blood culture. Could it be possible to identify microbes directly from clinical samples? Dr. Oberheitmann, are you there? Dr. Oberheitmann, I think your connection is frozen. Dr. Oberheitmann? Dr. Oberheitmann, are you still there? Just a moment, let me try to get in touch with Dr. Oberheitmann. Just hold on for a short while. We'll try to get Dr. Oberheitmann back online. Do keep your questions coming. We're trying to get Dr. Oberheitmann back online. I will read out your questions once we have him back with us. Dr. Oberheitmann, are you back with us? We'll give Dr. Oberheitmann another chance to log in. Okay, let's just give him a few more minutes. Oh, yes, Dr. Oberheitmann, we can't hear you.
Do you hear me now?
Yes, I can hear you now.
Oh,
Okay.
sorry
Yes.
for that. Really, I don't know what happened.
Okay.
Okay.
So the second question from Dr. Jacinta was, you mentioned that it is possible to identify microbes from blood cultures. Could it be possible to identify microbes directly from clinical samples?
Yeah, what do you mean with directly? You mean without a first primary culture?
Yeah, I guess it.
Yeah. Mm.
I think so. That's what
Yeah.
Dr.
Well, the
Jacinta.
problem is always in blood culture infections, you have usually single organisms in this. And if you have a direct, you might have different ones. You have maybe interact with bacteria or something like that. So not really possible. You need this pure colony.
Okay. Her third question was, is it possible to detect antifungal resistance? If yes, is this detection limited to particular resistant mechanisms?
We just recently started to work on this fungal resistance. I can't tell you now if it's really working and how. In principle, it works. There has also been some publications out, but we don't have a product yet for that. So there's hope that it will work in the future.
Okay. We have a question from Dr. Mohammad Faisal. It's a technical question. For filamentous fungi, which part of the colony is the best to pick for process using MALDI-TOF? Is it the central part of the colony or the peripheral? Or are there any other specific sites preferred?
Yeah, the front mycelium is always it should be material which is not very differentiated. If you you pick material with already some spores or whatever on it, this might disturb the process. So the earliest front mycelium would be the best to pick.
Okay, there is a question in Q&A from an anonymous attendee. Thank you for the talk, Dr. Oberheitmann. Is there an indication what type of filamentous morphology is more suitable for which method, i.e., is the EDT, extraction, liquid cultivation?
Well, in the liquid, even if you inoculate with spores overnight, you will have a very undifferentiated bubble of fungal material in your tube. Then because it's turning upside down the whole night, there will be no differentiation based on the G forces, because what is happening in a fungal hyphae is also that it starts growing from in this situation. So that means in the there is no differentiated status in this overnight culture. And if you're starting from the agar, either from using the EDT sample preparation method or the liquid, the extraction from agar, in both cases, you should use as early the material as you ever can. So in the moment you can see it just on the plate, a very early, just small colony, then you should take it. In some cases, of course, they are growing so fast that overnight you have already a kind of weed there on your agar, but it's always the principle is to harvest as early as possible. All kinds of differentiations lead only to problems. So also for the extraction method and also for the EDT method. Just take very early fresh material, white, hyphae when possible.
Okay, Dr. Jacinta has another question. Is there a limit of detection in terms of number of colony forming units needed for identification by MALDI?
You need only one colony, because if you have a colony, you can use the material. So, and what you see is always enough to do the testing. So if you can see it, it's enough. This is true for the agar and also for the liquid. If you see anything, it's enough.
Okay. Dr. Humaira has a hand up. Not sure. Is there a question? Any more questions from anyone?
Yeah, there was some new in the chat now.
I think you answered that question earlier.
Oh, okay.
Yeah, how fresh the colonies should be, and it should be as fresh as possible.
Okay.
Dr. Humaira has a hand up, but she have a question. Does anyone else have any questions for Dr. Oberheitmann? Dr. Jacinta would like you to explain more about the MBT substitutor IVD kit. Which microbes can be detected?
In principle, you can use the material for everything what is growing in it. So if you apply it now, because before we didn't had an IVD fungi method, so it was not validated for fungal material, only for bacteria and yeast and for mycobacteria. You can use it for that. For the fungal, the real filamentous fungi, there is no reason why it shouldn't work there. But up to now, we don't have any studies on that based on, because it's also something which is not too frequent to have filamentous fungal material in blood cultures. But in principle, it should work.
Okay. There's one more question in the Q&A from an anonymous attendee. How do we deal with fungal balls when using liquid cultivation that is hard to be broken down?
Yeah, here again, it is also always good to harvest as early as possible. Then you have these balls a little bit smaller, and usually with the extraction method, you will finally have some material extracted, even if there's something left which is not completely destroyed. But here again, it is also the better you when you harvest it just overnight, or even some only 12 hours or something like that, so that you don't have this very thick balls in the tube.
Okay. Dr. Jacinta asks, how about the MBT star BLIVD assays for resistance detection? Does that detect only antibacterial resistance?
Yeah, this is only for bacteria at the moment. So for the fungal resistance, we don't have a product yet.
Okay. We have a few more minutes. Okay, another attendee asks, you mentioned when the toothpick is coated with formic acid, it will cut the agar and it is easier to pick the mycelium for smearing.
Yeah.
Will picking the agar impact the result?
It's not cutting the agar, but cutting the fungal material. You should avoid cutting the agar because the agar will maybe bring you some proteins in which might disturb. So the idea is to only harvest with this. You can cut the fungal material very nicely and also avoid using material which is already sporulated or have some, you only want to have this very early front mycelium, and you can, in some cases, it's hard to, when you don't have this knife, this chemical knife with formic acid, it's hard to harvest material without bringing in already sporulated material or otherwise differentiated material. So don't cut the agar.
Any more questions? Dr. Oberheitmann, in your field, for MALDI talk, what is the biggest challenge you faced?
Well, the taxonomy, especially in fungal taxonomy, there's such a volatile changing because we're now entering in more and more in DNA-based taxonomy and all this kind of. Now we recognize that some species which were described before aren't really different, or the other way around, that some are very closely related, which or are more different than it was expected because morphology and so on. So that's always a challenge, and also the availability of DNA sequence information, which is relevant in many cases. The ITS sequences and others are not enough, so you have to go for other target genes and so on, and whole genome sequencing can overcome that a little bit, but you can't really whole genome sequence everything. So that's a challenge in this field. And also, yeah, what is also very interesting and for us is to if you have spectra of species where you see, okay, the spectrum should be good, but it is not represented in the database, we would be interested in receiving the spectra and in some cases also receiving the strains to find out how we can target our library expansion or extension by gaps we have which come up in a clinical setting. So that's also a challenge too, because we want to target, of course, those species which are there in clinical microbiology, and because especially in the fungal world, it's such a huge field of different species, more than bacterial species, and of course you can put in everything, but we want to target it, of course, a little bit, which is in general with what we have in it. Our 222 species already cover more than 90%, of course, or even more of the relevant species. But I mean, in the moment when you can't get it to a result, it's always good that we can introduce it in the future. So that's also challenging for us to get strains which are relevant. So if you have one.
So I think the next question is quite relevant. How can we contact you if you would like your advice and maybe send you some stuff? So how do we get in touch with you?
Maybe I can just paste my contact data here in the chat, and everybody can contact me in case. Let me just put it like here.
There is a question in the Q&A box from an anonymous attendee. The two questions. If there is visible different morphology in the liquid tube, is it recommended to repeat the tube cultivation if we suspect mixed culture? Or do we plate it out or just can transfer the material into another broth tube? What about bacterial contamination in the liquid tube? Is turbid appearance an indication?
Depends on what you have, what kind of material you have. A turbid is not an indication. So we have also turbidity just in pure fungal cultures. But anyhow, the good thing is you can also use the big database. And if you fear that something is bacterial contamination, you can just use the other database to check whether there are some log scores in a bacterial field as well. So that could be something. Yeah, it depends how, if you see different morphology in the liquid culture. My personal feeling is that it's already too long incubation. Yeah, that would help to recultivate, of course, but you want to come to a result as early as possible in many cases. I would just give it a try, and if you reach already green log scores, that would be good. It might be if you have different morphologies really indicating that these are two species, then I would repeat it and go back from a colony and re-inoculate again.
There is one more question. Dr. Boris, can you explain more about the in-house local database? How do we want to go about it? Is it by sequencing as well, like bacteria? then we build the database?
So if customers of us, not in the IVD world, no, it's just in the RUO world, research use only. They can build up own databases if it helps them. Yeah. So, but in general, at least in Europe and in the US, of course, as well, it is not allowed to use these kind of homebrew things anymore because we have this much stricter IVDR regulation now. And also in the FDA world, in the US, these homebrew assays are really, it is, it's complicated. No? So you can take the risk to use it and do diagnostics with it, but it's your own responsibility. There will be no reliability of Bruker or of any other company if you are not using IVD CE marked products. So if you want to do it for research purposes or also to just because you know there are good reasons to have an own one, maybe because your particular species you frequently find are not covered or whatever, then you have, of course, to be sure what you introduce there is really what you mean it is. So sequencing is one thing, and that is what we are always doing. But even that can be a bit blurred, because the DNA, the difference between fungal species might be not too much. So, and that's always, you have to balance. No? So if you really want to build up an own library, you have to be sure what you introduce there is really the species you think it is. So our experience is that when we receive from a culture collection, from wherever, from collaboration partners, 1 in 50 strains, or 2 in 100, 2%, are wrongly identified. It is also when we send out something, because it happens that there's a contamination or any, I mean, that's a rule we have. 2 in 100 are wrong. Just by any other method, even sequencing, or so, that can happen. So, and if you do not pay attention, that you reduce this or you identify this, then you can come up with a database which is not accurate enough. So, yeah. And we have this standard operation procedure, how we do it. We compare it to each of our existing libraries, and also we have further which are not commercially available. So we can really, do not only the DNA sequencing, but also comparing it to existing databases. So others also. And that helps us to be sure on the MALDI side. And also the DNA side might also be blurred a little bit. So because,
Okay, thank you so much, Dr. Oberheitmann, for spending your morning with us. The time difference now. It was a very informative session we've had today. We are very, very pleased to have you with us. Thank you to all our attendees for joining us for our CME this month, and we hope to see you for our next CME. And thank you, Dr. Oberheitmann, and have a pleasant day.
Okay, thank you. Bye then.
Bye.